This video goes over some more examples of solving trig equations. So recall, to solve a trig equation means to find the value of x that is going to make the equation true. So let's start off here by rearranging for cos x. We've got minus 2 over 3. My next step is going to be to figure out where cosine is negative. So that would be here and here. And now I'm going to find my related acute angle, which is the cos inverse of my positive value of this one here. So doing that on my calculator, I would find that my related acute angle is 48 degrees. I use my calculator here because 2/3 is not one of my special triangle angles. And I know that this value here is my related acute angle. So that means that my first solution for x is in quad 2, and x is going to be 180 degrees minus 48 degrees, which is 132. And then my solution in quad 3 is going to be x equals 180 degrees plus 48 degrees, which gives me a final answer of 228 degrees. In my next example, I've got cos x equals 2 sine x cos x. In between, well, really we're looking at between 0 and 360. So the first thing I'm going to do is I'm going to bring everything over onto one side. So 2 sine x cos x. Let's see, if I bring that over to the left side, it becomes minus, and then I've got cos x left over and a 0. Now I can't really rearrange this for a trig ratio, but I can actually factor out cos x. And now I've got two items to solve here, each with their own trig ratio, so I can do that. So my first one is I've got cos x is equal to 0. This means that my x value is going to 0, or my opposite side. That is going to happen when my terminal arm is right on the boundary between Q1 and Q2, and it's going to happen right on the boundary between Q3 and Q4. My cos x is equal to x over r, so I need that x component to be equal to 0. That happens when my terminal arm is right up and down. So my two solutions here are 90 and then 270. And now I've got another equation to solve over here. So this one I do have to rearrange. So I get sine x equals 1/2. I know that I've got two solutions here as well, in my first quadrant and in my second quadrant. I'm now going to find my related acute angle, which is 30 degrees. Comes from my special triangle, if you remember here. So root 3, 30, 60, 1, and 2. Okay. And then the next thing that I'm going to do is figure out my two solutions. So in quad 1, my angle is equal to my related acute angle. And then in quad 2, my angle is equal to 180 minus 30 degrees, which gives me x equals 50 degrees. Let's do one more example. I've got 6 sine squared x minus, we're going to do this as sine x minus 3 equals 0. And we're going in between 0 and 360. So I can't rearrange this. I can factor it. Really, I'm trying to factor the expression 6a squared minus 7a minus 3 equals 0. Using my tricky trinomials, I can factor this to 2a plus 3, and then 3a minus 1 equals 0, which is then going to give me two brackets or two expressions that I'm going to set equal to 0 and solve. So let's take a look at the first one. I've got 2 sine x plus 3 equals 0, which means that sine x has to equal negative 3 over 2. Okay? So here, all of a sudden I'm going to see that this value is greater than 1, and this means that there is no solution. You can actually only take the inverse sign of values in between -1 and +1. Okay, so no solution, great, means that there's less work for me to do. My second bracket, I've got 3 sine x minus 1 equals 0, which means that sine x equals 1 over 3. I'm going to draw my quadrants. Notice that sine is positive in quadrant 1 or quadrant 3. Then I'm going to find my related acute angle by doing the sine inverse of 1/3. I know I need to use my calculator here because it's not one of my special triangle ratios. Doing that on my calculator, I'm going to get 19. And then my solution in quad 1, x is equal to 19. And then my solution in quad 2 is going to be 180 minus 19 degrees, which is equal to 161 degrees.